Hello, everyone. So this is AIME 2023 AIME 2, number 12. Okay. So we have a geometry problem with actually a bit trick involved. So let's take a look at it. So we have a triangle, ABCD sides are given. Okay, M is the midpoint of side BC, and P is the a point on the circumcircle of the triangle ABC such that M is on AP. Okay, this is kind of not obvious without actually having a picture. Since we are told there is a circumscribe of that triangle, right? Which is why we do need a circle. So let's go ahead and maybe start with them. So if I have a rough picture of ABC, so it might be something like this. Okay, so let's say this is A, this is B, and this is C. So AB was 13, so that is 13. BC is, okay, this guy. But at the same time, we have a like point M, which is a midpoint of BC. So we should have just right in the middle. So I'm gonna call that M. And since BC was 7, so these guys are 7. I mean, BC was 14 and CA is 15, okay. And since we are told AM is our midpoint, so I can connect that as well. I mean, M is the midpoint, so AM will be the median. So, and then there exists a unique point Q on segment AM. Okay, there is point Q on this segment such that the angle PBQ, okay, where is P? P is the point on the circumcircle of ABC, okay, such that M is on AP. Okay, so this is A, M is right here. So when you have this line segment, when you extend in both directions, there should be a point P. That point P has to be on the circumcircle of the circle, which means if you do so, you will actually get P right here. So let me actually extend this. Okay. And we are told this point is P. Okay. And it says the angle PBQ. So PB, and there's a P like Q right here. So I'm gonna connect this. So there is a point like somewhere right here. Let's assume there is Q right here. Okay. And it says the angle right here, maybe I should use different color. So the angle right here is the same as PCQ. So P right here, C right here, and Q right here. So let's connect those as well. Okay, so the angle right here is the same as this one. So based on this figure, you can like assume since this guy is same as this guy, so the opposite angles in equilateral is the same. So it might be a parallelogram. So let's actually try to see if that's really the case. Okay, and then AQ, which is this distance, can be written like this, and we are looking for some. Okay, so I don't really know if this is a parallelogram at this point, but it's kind of suspicion that I have because these two guys are equal angles, right? So let's assume, okay, let's assume this distance right here, MP, is the same as PQ, right? And I mean MQ. Only if this is same as this one, which means this is gonna be the point M is midpoint of PQ, but we already know M is the midpoint of BC. So if you have two diagonals are intersecting each other, right? That has to be a parallelogram. And if that's a parallelogram, the opposite angles are going to be equal. So these two guys are equal. So from there, so you can say if these two guys are equal and then one diagonal is actually like bisecting the other diagonal, then this actually also the diagonal of that parallelogram. So which is why this piece and this piece has to be equal to each other. So that is actually nicer to see because I'm going to actually use this point as well. So at this point, some people are probably going to remember the median length formula because we have a midpoint right here. So you can use it. but I'm not gonna use it for now, at least for those of you who don't know, but I'm gonna use the log cosine. So let's call this angle is alpha. Since we are talking about this segment, AM, and we have other two segments, and then same thing with the other triangle, I'm gonna use the log cosine in this triangle. So that will be 13 squared equals 7 squared plus, I'm gonna call AM as maybe X or just AM itself, but I'm gonna call X. So X squared minus 2 times the side 7 and AM, so 7 times X times cosine. So I'm assuming this is going to be a cube, and then this is going to be obtuse because this is 13 and 15. So that will be cosine alpha. And if I use the log cosine on the other side of that angle in this triangle, so that will be 15 squared equals 7 squared plus x squared minus 2 times 7 times x times cosine of, since this was alpha, so the other side will be 180 minus alpha. Okay, so I hope we remember, whenever you have two angles are supplementary of each other, the cosine of one angle actually negation of the other angle. So this piece is the same as negative version of this guy. So which is why if I wanna kind of not deal with this difference, I can make actually this guy minus, which will make this plus, and then I can make actually this is cosine alpha. So let's do that. So then this guy will be plus. So now we have a couple unknowns. Maybe we can simplify a bit. So if I subtract the first equation from the second, it looks like we will get something better. Okay, so let's do that. So if you subtract those, so 15 squared minus 13 squared, so these guys will eliminate each other. And if you subtract this, this will be plus, so that will be 14x times cosine alpha. That's also 14. So that's 28 times x times cosine alpha. If you see this in different size square, that's 15 minus 13 times 15 plus 13, which is 2 times 28. So 28 will cancel. So 2 is equal to x times cosine alpha. Okay, this is good so far. And my next point, I'm gonna plug this guy. There is two things right here that I don't know. I'm gonna plug into this for that equation. Let's use the first equation. So I had 13 squared. Okay, let me use different one. So 13 squared is equal to 7 squared plus x squared minus 14 times x times cosine alpha. So we know this piece was equal to 2, so I can replace with that. And that's 169. That's 49. If you subtract, that will be 120, which is equal to x squared minus 28. Add 28 to both sides, so you will get 148. And I guess we can pull this 4. So if I pull 4, so that should be 4 times like 3, which is 12. Okay, 7. So if you take the square root, the x will be 2 root 37. Again, if this process is a bit longer, so it's maybe better to use the median like length formula, which will be given this as well, okay? But anyway, I just use the log cosine. So now we know AM is equal to this guy. So let me make it clear. So that's my AM. But that is not what we are looking for. We are looking for the AQ, which is this guy. And if I know this guy or this guy somehow, then I can actually find what I wanted. But from here, so we don't really know that yet. But at the same time, this guy is a point of the intersection of the two diagonals in a circle, which reminds me power of points. So in the power of points approach, we can multiply 7 by this 7, which will give me this guy. If I call this is maybe like y times, the other part will be AM, which we already know, okay, 2 times root 37. So the y should be 49 over 2 times root 37. Okay, so it's not really nice, but at the same time, our denominator is gonna be radical. So this is y, which is equal to MP. Okay, so let me write that. And this is the same as QM. And the question was asking AQ, so then we are actually done almost. So the AQ is equal to AM minus QM. So that's gonna be 2 root 37 minus this fraction, so 49 over 2 root 37. And if you simplify this, you can like make the common denominator and just get the final answer. So I guess that will be 99 over 148 on the radical, okay? So I hope that makes sense. So again, that's basically just simplify this as much as you can. And that is my final answer. And if you're given these guys as M and N, so you just need to add these, right? So 99 and 148. So I guess that's gonna be 7, and that's gonna be 4 and 2, okay? So 247 is the answer. So there might be some other ways, but I think using the log cosine is not too bad idea, okay? So I hope that makes sense, and I'll see you in the next video, okay?